Welcome to Carbon Chemistry classes. Today our topic is Basic Concepts Part 2. In the last part we have seen nucleus, some terms related to the neutrons, protons and electrons, isoelectronic species, isodiaphers like that. Today's topic is laws of chemical combinations. Laws of chemical combinations, in which we are going to study 5 laws, the namely first one, law of conservation of energy. Second one, law of definite proportions. Law of multiple proportions. First law of conservation of energy. This is the basic law, all of you know and you are aware of that. Law of conservation of energy means energy neither be created nor be destroyed. If you apply the same law, actually the same law in terms of chemical things, that is masses of the reactants, sum of the masses of the reactants are exactly equal to sum of the masses of the products. So if you write the definition, sum of the masses of reactants are equal to sum of the masses of product. For example, reactants are going to give products. Reactants are going to give products. So mass of R generally equal to masses of products. A real example I can give. For example, CaCO3. CaCO3 on thermal decomposition, it going to produce CaO and CO2. CO2. If suppose 100 grams of CaCO3 is going to decompose, so generally, so the mass, sum of the masses of CaO and CO2 are formed on the product is exactly equal to 100 grams. For example, this is 56 grams and this is 44 grams. So, according to law of conservation of energy in terms of chemistry, sum of the masses of the reactants are equal to sum of the masses of the products. Second law of definite proportions. It states that the same chemical compound is always composed of the same elements combined together in a same or a fixed proportions. For example, this is indirectly, irrespective of the source, the chemical compound is always contains same ratio of masses of the elements. For example, water I have. First case is this is collected from the rainwater and one which we have prepared in the lab water. So if you take the chemical compounds, two molecules of hydrogen means two atoms of hydrogen and one atom of oxygen. Here two hydrogen and one oxygen atom. So if you take the ratio of hydrogen is to oxygen, here it is 2 is to 1. here it is also 2 is to 1. Even if you take the mass ratio 2 is to 16, here also 2 is to 16. So what it means, either it is from lab water or the rainwater, irrespective of the source, it contains always same composition of the elements with respect to their masses. Third law of multiple proportions. It states that if two elements combine together, if two elements, so it's element 1 and 2, combines together to form the several compounds, that compounds are C1, C2, C3, then the weight of these elements in which combines with a fixed weight of other, one which is fixed weight which is going to combine with other element, or in the ratio of simple whole number ratio. Fixed weight of sulfur, like fixed weight of sulfur, let it is 32 grams of sulfur, going to react with oxygen to form several compounds, here two compounds. So S is going to react with oxygen to form compound 1 is SO2 and compound 2 is what, SO3. So one which is fixed weight, the element which is fixed weight, what is fixed weight element here? Sulfur, going to react with other, combines with other, what is the other element here? Oxygen. So in the first case it is 32 is to 32 and here 32 is to 48. So fixed weight, right, and the remaining two, what is 32 is to 48, these two are also in the 1 is to 3 ratio. This is also, sorry, this is 2 is to 3 ratio. Law of reciprocal proportions. It states that two elements A and B, let two elements are A and B, combine with a fixed mass of an element C. For example, A and B elements are there, combines with a fixed mass of C to form two compounds. Let the two compounds are A and B, suppose AC and BC ratio of, to form two compounds, then the ratio of A and B in these two compounds, A and B in these two compounds, what are those two compounds? AC is to B. In these two compounds, if we take weight of A and B, so the respective weight is suppose A and the respective weight from the compound B, if you take this ratio is always the same, or simple whole number ratio. Simple whole number ratio. For example, I will give one example to understand in a better way. Yes, sulfur and oxygen. Sulfur and oxygen going to react with the same amount of H to form two compounds H2S and here H2O. So what are the two compounds we have? H2S in one compound and the compound is H2O. Here A and B, what is A and B? Let A is S, B is O. A and B going to form two compounds with common element H. So H2S and H2O. Here if you take the weight of S, for example weight of S in compound 1 and weight of oxygen in compound 2. So this is 32 and this is 16. So 2 is to 1. Or we can say the ratio of elements. How many atoms are there in this one? 1. How many atoms are here? 1. So elements, if you take, the ratio is maximum, or most of the cases is same. If you take the weight ratio are in simple whole number ratio. Fifth law, Gay-Lussac's law. It states that when gases react together, they do so in volumes where in a simple ratio with the volumes of reactants and products also. For example, one example, if gas is N2 gas and H2 gas is going to react to form a gas product is ammonia. So what is the balance equation means N2 plus 3H2, 2N2 plus 3H2 gives rise to 2NH3. So what is the ratio of N means NH2 and NH3? So gases ratio of N2 and H2 is to NH3 is 2 is to 3 is to 2. Wherever N and hydrogen means hydrogen and nitrogen combines, they can form ammonia always in this fixed ratio 2 is to 3 is to 2. 2 is to 3 is to 2. Right? Thanks for watching.